Hello and welcome back. We're finishing off this week's discussion around legacy systems by talking about how we can add features to our legacy system safely. Let's jump right in. So there is a golden rule, and the golden rule is do no harm, right? Existing behaviors might be relied on in hidden ways. We might not know. When we come into a project for the first time, it can be very tricky to sort of discern all the different connections that could possibly exist. And we really need to understand that if there aren't a lot of existing tests and the infrastructure around the code doesn't exist to maintain it, it means that there's a risk that we could break something and not even know, right? We could have this silent breakage. So very large changes all at once can multiply the complexity of the project. It can increase our debugging time in the project. We don't want to come in and just start swinging a sledgehammer around. So the very first thing we're going to do when we're ready to start adding new code, after everything else we've already discussed in this video suite, is to add some tests first. The very first thing we're going to do is add what are called characterization tests. And these will allow us to lock in the current behavior and get a better feel for how the current behavior is working. Even having minimal coverage that we have now written will help us build confidence that when we make a change, we aren't going to break core functionality. Right? We need to focus these tests in on the parts that we have to touch, but I mean, of course, the more tests, the better as well. Now, when we're adding new code, we really want to try to isolate our new code, and this means that rather than modifying existing code and modifying code that already, is scaffolded within the code base, we're going to bring in our own brand new file. We prefer to extend the code over modifying it. This means that we can keep all of the old code paths intact without touching any of them and still safely integrate our new code into the project. We also want to make sure that we are doing small changes, commit early, commit often. This way, if something does break, it's very easy for us to spot what it was and revert it back. Now, another tactic that we might want to take is that we're going to use feature flags alongside of our isolation. Whenever we add new features, we want to be able to use a feature flag so that we can add it without risking the whole system. This allows us to control our rollout, and we can even test in production-like environments without having to worry about breaking everybody's environments. It also means that if some problem does occur, we can just really quickly re-disable the new feature and then figure out how to, roll it back or what the heck is going on later. We definitely will need to, but this can sort of prevent large long-term outages in our projects. We can also sort of get this isolation that we're talking about and this wrapping of our new features in their own class spaces by using adapters. So if you think back to a few videos, weeks, whatever ago, and we talked about the adapter design pattern, this is a fantastic place where it can be used. It allows us to keep our new logic separate from all of the old code paths, and we can use an adapter to connect the old interface that exists wherever it is to our new implementation, right? This allows us to also test new code in isolation from all of the old stuff, and we can swap out our implementations without crazy refactoring and super deep rewrites. So we want to do our best to wrap existing code in some kind of an adapter or a decorator, and then we can create a new class that will implement that same interface, right? So we have our new class, that is our wrapper, that's our adapter, and it can house, we can do like a composition style design pattern where the old code can now be wrapped up in this, and we can delegate all of the old code stuff back through the old code so that we don't actually end up changing any of that behavior. And then just where we need new logic, we can have those funnel through this adapter into the new logic, right? This keeps our original tested paths completely intact. It might mean that there's still code debt. It might mean that there's still refactoring we could have done, but we know we're not breaking anything. Then we can define an interface if one doesn't exist yet, right? And we can add our code to the interface rather than adding our code into a legacy class directly. So if we do need to add, let's say, security protocols and validation to old existing code, rather than altering those methods directly, we might want to instead make a new interface and then be able to swap in our new implementation without disrupting that old space as too much. And like I previously had mentioned, we are going to try to favor this idea of composition over inheritance, right? We want to make these new classes that are composed of these old pieces and then our new functionality, rather than trying to, create some kind of extension inheritance situation. We want to compose our behavior by holding an instance of that legacy code class rather than subclassing it, because inheritance might force us to carry through behavior that no longer is valid, whereas our wrapper situation allows us to sort of define that new behavior in a more isolated fashion. Composition is going to give us a bit more fine-grained control over what we do want to reuse. Now, as we said, maybe we're doing this composition, we're using adapters, and this might leave behind some tech debt. This might be a sort of avoiding a refactor. But that's not its intention. We still want to refactor as we go, but we do want to make sure that we're only refactoring as much as we need to support our change. We really don't want to be the hero. We don't want to do giant rewrites, especially in these, more fragile systems. So there's this idea of sprouting that was developed by somebody named Michael Feathers, and it's this idea where we're going to create new classes or methods rather than making any code changes to the old ones. So rather than doing any refactoring to those old ones, we want to make these new ones. Our root will call from old code into the new structure. So our old code may need a very minor change, like calling our new interface or our new class, and then our new class can handle the reroute back into the old structure, as we said, right? So this is going to reduce risks to existing behavior, and it means that we get to write the tests for this new interface, this new class, completely sprouted off, separate, totally independently. Whenever we do any kind of refactoring in legacy, we need to leave some breadcrumbs behind. Now, we have said that leaving to-dos in code or comments that say, I don't know why this works, is bad practice because it's tech debt. And that is still true. We are creating more tech debt. But we also said that tech debt is unavoidable. So in our new systems, as we're going forward, let's not leave behind to-dos when we're actively working on it and can make better choices. However, if we're working with a system that doesn't have that stuff already available to it, this is the time to leave behind comments and to-dos, right? We want to test scaffolds, and we want to write minimal tests that are going to capture what's going on. Even if it's not perfect, even if we're just adding a little bit each time, it will help future maintainers, including probably yourself, pick up where you left off, figure out where you were. If you've ever tried to finish working on something on Friday and then leave it until Monday, not look at it again until Monday, and then you come back Monday and you're like, what the heck was I even doing? You need to leave yourself breadcrumbs, and that's what we're talking about here. We're not leaving tech debt as a way of saying, I'm not dealing with it right now, I'm just going to leave it for somebody else. We're leaving these breadcrumbs so it can be dealt with. It's very different. All right, so interesting case study here, replacing legacy checkout with the strangler fig pattern. So I had mentioned this pattern of sprouting. Now I'm going to talk about a different one here. It's called the strangler fig pattern, and it's really interesting. So imagine we have some legacy code here called the legacy checkout service, and it is just a big tangled God class. It calculates totals, and it does discounts and taxes. It calls to the database. We have all the concerns that we know we don't want to have in here, right? We end up with that monolithic class. And our goal is going to be to replace the discount and tax logic first, and then we will gradually do the rest without breaking our production environment, because even though this checkout service is a disaster, it does work. So we don't want to break production. All right, phase 0. What are we going to do? Let's characterize the current disaster that is our code base, right? Let's make ourselves that golden baseline and lock in what correct means before we touch any code. So right now we have this legacy checkout service, we make our new legacy database, and we can write some tests that ensure that whatever is currently happening, we're documenting, and we can sort of make sure we're ensuring current behavior is maintained. Then we have phase one. Phase one, is when we introduce a facade. And this is going to be also known as the strangler front door. We're going to create ourselves a small interface in front of that legacy code. And everybody is now going to call through the facade instead of directly depending on the legacy code. This is basically just a dependency inversion, right? This is dependency inversion principle in action. So rather than this calculate total happening right here, right? We were calling our service .calculate total. That was the method we needed access to through the service. Instead, we're going to create our interface. Look, teeny tiny interface. It's not for the entire legacy, it's not for the whole service. It's for a single method right now. So we make our single method interface. We go and make our new class, our checkout strangler class. This is going to be our facade, and it's going to implement checkout right there. Now our private final checkout legacy is going to have our adapter to the legacy right here. We have our new implementation slice, and we can have our feature flags. So this is our strangler class right here. And everything gets passed in, our old checkout code, our modern code, and our feature flags. Right here is our calculate total method. We are overriding the old one. Right here, if we want to use our new way of handling checkout, we totally can by calling modern.calculateTotal with our card ID. Otherwise, we can just fall back on that old one, the legacy one's calculate total card ID. So now let's actually talk about introducing this adapter, right? We need this adapter. So let's make a legacy checkout adapter, which also is going to implement checkout. This is where that legacy checkout service is going to be housed. The composition happens inside this adapter here. So we have our legacy checkout adapter, and we're going to pass in this legacy value. And then we can also implement calculate total, passing in the card ID with that unchanged path right here. All right, lastly, we need to implement that feature flag. And our feature flag is super trivial, very straightforward. We're going to make a set of strings, right? And we're going to determine whether or not a feature is enabled, because we could be doing this for multiple features. Right now we're just talking about the calculate total, but like we said, there's discount, there's taxes, there's promotions, whatever, right? There's lots of different things that may need feature flags in the future. So we scaffold it within a class. It's not just a single Boolean. We can enable and disable features through this final class. All right, and now let's wire it all together. So now we're going to create that feature flag variable. We're going to create our checkout. Our checkout needs to be a checkout strangler, right? It's going to be what's actually putting the hold on either side of this checkout feature. We're going to put our new legacy checkout adapter inside. This is like a kind of crazy line of code, but you'll notice that right here, this is how the old one was being defined. New legacy checkout service, new legacy DB. That is still there. We're just now wrapping it up inside of our legacy checkout adapter. And then we're also passing in our new modern checkout. Our new modern checkout can take in the pricing service that we created, the tax service that we created, the separate cart repository that we created, because we wrote beautiful, well-designed code. And then the checkout strangler, if you remember correctly, is going to basically figure out, using that feature flags right here, are we going to use the legacy or the modern checkout? Here it is right here. Oh, this is our modern. Sorry, this is our modern checkout that has the pricing service, the tax service, the cart repo, all those different pieces that were all mixed up before are now composed in this modern checkout service. And right here we can see how the calculate total looks very different. The old calculate total goes through that legacy service that's probably giant and crazy. Here we get each of our pieces nice and individually, pull it all together to do our computation, and then return whatever our money is. Okay, here's that cart repo as well. We can see that we have defined the cart repo. I don't think I show like all of these, like the pricing service, the tax, and the cart repo, but I do show the cart repo here because we can see that the cart repo is an interface where we're loading our cart by ID, and we can have the legacy cart repo, whatever already exists, totally already exists. All we're going to do is add the words implement cart repo into the class name. because we're not even changing the name of this. This previously existed, and the legacy database already did all of that. We're not going to change any of those things. We're just going to add this load class to this interface and then say, surprise, now you're implementing an interface, so that we can then go and like wrap around it appropriately. Now here is us doing some kind of a test, right? We need to be able to compare our outputs and ramp ourselves up to that flag. We want to keep both paths alive at the same time. We want to be able to prove equivalence, right? We want to say that these are working the same within whatever our tolerance level is before we actually switch traffic over to our new path, right? And then slowly strangle out our old one. Okay, so we have our flags here, and we can keep our modern off for production traffic, right? That allows us to say if we're going through production, keep using the old stuff. Only now, when we want to wire everything up in our test situation, we can appropriately use our modern container if we need to. So for each of our IDs in our sample cart, we made a sample cart. We can try to find out what the money comes back as using the legacy system versus what the money comes back as for the modern system. You'll notice that we have a force legacy tag here for true and false. So the legacy, yeah, use legacy. Modern, do not use the legacy, right? Use the modern system. Then we can assert that those are the same within a certain amount of, percent or dollar amount. Okay, once we've done all that and we can make sure that everything is nice and compared, we can hit the actual rollout plan. We can enable the flag in a development environment or a staging environment, right? In production, we can sort of trickle users onto this new pathway. So rather than just doing everybody's going to use our new modern system, maybe 1% of users, 2% of users, 10% of users, right? Slow trickle until we know that it's stable. Once we know it's stable, we can leave that flag on permanently. And then once we feel good about that, we can delete the legacy path. We didn't intermix the two pathways, so we can just delete the old legacy path because nobody's using it anymore. Right? After we've got all of that going on, we iterate. We extend this strangler to more and more and more endpoints. So we add more methods to check out. We create additional strangler facades as we go. And each time we add that interface, we route through the strangler, we build the new isolation classes, services, and tests. We compare those behaviors, and then we flip the flag. And we can keep doing this very slowly, allowing our strangler fig to sort of take over and delete the old endpoints while amassing this new, well-designed modern system, right? Phase 5 is removing those old vines. Once that slice is totally integrated, right, we let it sit for a little while. We know the feature flag works as always on. Let's delete those legacy methods and let's get rid of their adapters. We can collapse the feature flags now, right? We can basically set the default to always be on and then remove all of that extra old code, remove any dead tables or columns that we're not using anymore. And again, whatever a safe window here, whatever that might be, is sort of dependent on the system and who's doing what. But that's usually defined by somebody other than you as the developer. All right, that is the end of adding new features to a legacy project. If you're looking for a little bit of a challenge, I would recommend that you, as part of your pause and reflect, go into GitHub, like public repositories of GitHub, or even maybe just a fellow group's project if you're looking for something dialed down just a little bit in terms of challenge, and pick a small feature and try to implement it into that project without modifying any existing body of code. Again, that doesn't mean you can't add implements my new interface, right? That's not the method body or the class body. That's just adding that little implements a given interface and see if you can do it. It's actually not as hard as it sounds if you follow through the steps of methodically understanding the project, finding that seam, adding that adapter and facade, and strangling it very slowly off with your new feature flags and code. It's kind of a neat challenge to work through if you're looking for something to do, and it will definitely allow you to start to contribute to more open source projects or older projects that exist. When you magically find the time as a not at all busy student, right? Okay, thanks everyone for joining me with this, and I will see you in our final topic, week 10, where we finish off our course. We finish off all of our course content. Thanks, everyone. Bye.